Okay, let's unpack this. If a single piece of machinery breaks down on an oil and gas rig in the New Mexico desert today, the drilling company could face like hundreds of thousands of dollars in delay penalties
Yeah.
before tomorrow morning.
Oh, absolutely.
And that is the hidden reality of modern heavy equipment. So today, we're taking a look at this massive high-tech engine that is absolutely driving regional economies.
Right.
But it's operating completely out of sight of the average person.
We tend to view construction equipment as, purely mechanical.
Yeah, like loud, dusty.
Right, dusty brute force tools, just moving dirt around.
Right.
But the materials we are analyzing today, well, they reveal a totally different picture. We are looking at highly strategic precision business assets.
Okay.
Where the engineering is deeply tied to really complex economic models.
Yeah, we've got a fantastic stack of sources for this deep dive. We're pulling from business briefings, engineering documentation, and company literature.
Right.
It's specifically focused on Southwest JCB down in Las Cruces, New Mexico. And, setting the stage here against the backdrop of the Oregon Mountains. There's just so much going on.
There really is.
So the mission today is to look way past what the industry calls heavy iron. We are analyzing the physics, the economics, and the cutting-edge engineering that physically construct modern society. So the next time you walk into a home improvement store or, drive over a new highway bridge, you are going to see the invisible choreography that put it there.
Well, the home improvement store is actually the perfect place to start.
Oh, really?
Because we associate heavy machinery with outdoor earth moving.
Right, like digging holes.
Exactly. But some of the most critical applications actually happen under a roof. Big box retail and massive industrial warehousing, they rely entirely on compact vehicles to maintain their economic models.
I mean, the retail logistics aspect is fascinating when you examine the sheer physics involved. You walk into a massive appliance outlet, and you are surrounded by these towering vertical shelves.
Oh, yeah.
The entire revenue stream of that store relies on scissor lifts, boom lifts, and a specific machine called a teletruck.
Right, the teletruck.
Which operates as a telescopic forklift.
I mean, safely retrieving a 500-pound commercial refrigerator from a rack.
Yeah.
Say, 20 feet in the air.
Terrifying.
Right. It requires immense hydraulic control and stability. These machines are the bottleneck for the entire operation.
Wow.
And beyond inventory management, they're essential for facility maintenance. Consider a local gymnasium or a massive athletic arena servicing high bay lighting or HVAC systems. It requires specialized access platforms to get technicians safely into the rafters.
It's kind of comparable to the backstage crew in a theater production.
Oh, that's a good way to put it.
The audience only notices them if the show stops. But the opportunity cost of that show stopping is severe. I mean, in the logistics space, uptime isn't just a maintenance metric.
No.
It is the ultimate measure of financial viability.
If we connect this to the bigger picture, the opportunity cost of a machine failure in a retail distribution center is staggering. I mean, if a teletruck's hydraulics fail, that high-margin inventory remains trapped on the upper racks.
You can't just climb up a ladder and grab a washing machine.
Exactly. You can't. Customer fulfillment halts, supply chains back up, and sales are, they're permanently lost to competitors.
Wow.
The reliability of these compact machines is a direct driver of corporate revenue.
So we've talked about precision in the controlled, flat environment of a warehouse. But the physics and the stakes completely change when you take these machines out into the rugged, unpredictable environment of the New Mexico landscape.
Oh, drastically.
Our sources detail the region's massive extraction industry, and the sheer scale of the operations extracting critical minerals is staggering. Right. We're talking specifically about copper, perlite, zeolite, potash, and coal.
Yeah, massive operations.
Setting up oil and gas drilling rigs or trenching complex pipeline networks, it requires heavy-duty dozers and massive excavators just to break the ground.
Because the mechanical stress on the undercarriages and the hydraulic systems in the natural resource sector, it's immense.
Yeah.
A machine tearing into hard-packed desert hardpan or ripping out volcanic glass like perlite.
Wow, volcanic glass.
Yeah. It is subjecting its structural steel to constant high-frequency vibration. and incredible breakout force.
That sounds intense.
It really is. The metallurgy has to withstand conditions that would shred standard consumer equipment in hours.
Okay, but let me push back on the economic framing in the energy sector sources here.
Sure.
Because the literature makes a huge point about equipment failure being catastrophic for oil and gas operations.
Right.
But given the massive capital backing those operations, is a broken excavator really a disaster?
Well, yes.
Because, I mean, they have deep pockets. A 24-hour delay for a replacement part seems negligible in the grand scheme.
You'd think so, but in the extraction industry, time is heavily penalized.
Okay.
Missing what they call a spud date.
A spud date.
Yeah, spud date. It's the contractual start date of drilling a new well.
Oh, I see.
Missing that triggers immense financial consequences. If an operation is delayed because the heavy equipment necessary to prep the site or lift the rig components goes down, they incur daily delay penalties.
And we are talking about six-figure penalties.
Yes.
Per day, just for a delayed start.
Hundreds of thousands of dollars evaporating because a single hydraulic seal blew.
Oh, man.
Or, an engine overheated. The reliability of this heavy iron is literally a financial hedge against catastrophic loss.
Oh, okay.
Fleet managers aren't just buying steel, they are buying guaranteed productivity.
Which means the engineering has to evolve to prevent those cascading failures.
Absolutely.
Especially when human operators are constantly running these machines in high-stakes, high-pressure environments. And that brings us to a major historical problem with the anatomy of the skid steer loader.
Right.
And a massive paradigm shift in how these machines are constructed.
The traditional geometry of the skid steer loader, which is the highly maneuverable, compact machine ubiquitous on every job site.
Yeah, we've all seen them.
Right. It utilizes a dual arm design. There is a heavy steel loader arm on the left and another on the right.
Okay.
Operating symmetrically to lift the front bucket.
So the sources outline two severe liabilities with that traditional engineering. First, the thick steel hydraulic arms block the operator's lateral vision, creating massive blind spots on the sides.
Yeah, which is dangerous.
And second, because the arms and the hydraulic cylinders take up the sides of the machine, the human operator has to physically climb over the front bucket to get into the cab.
Yeah.
That means stepping over a jagged, muddy attachment. Or worse, decking under a raised steel boom.
Slips, trips, and falls are significant liabilities, and forcing operators to navigate around a dangerous implement just to start their shift.
Right.
It's a structural design flaw.
So the solution presented in our deep dive materials is a complete redesign by JCB called the Power Boom. They abandoned the dual-arm geometry entirely.
Totally gone.
The machine uses a single massive loader arm mounted exclusively on the right side of the chassis.
And what's fascinating here is the counterintuitive nature of the physics.
Yeah.
Because the immediate assumption is that removing one of the load-bearing arms would compromise the machine's lifting capacity.
Right, that it would just tip over or twist.
Exactly, or make it structurally unstable. However, the engineers utilized high-tensile steel, significantly increasing the cross-sectional thickness of that single arm.
Okay.
They routed the structural stress down a fortified line in the chassis, making the single-arm geometry demonstrably stronger and more rigid than the conventional two-arm models.
That is wild. The single-arm design completely clears the left side of the machine.
It does.
Here's where it gets really interesting. By opening up that left side, they were able to install a side entry door.
Right.
The operator simply walks up to the machine, opens the door like they would on a standard car, and sits down.
Just like getting into a truck.
Yeah. It's like, trying to drive a car with two thick steel pillars blocking the side windows. You wouldn't do it.
No, of course not.
The biggest safety innovation on modern job sites wasn't an advanced digital proximity sensor or a complex AI camera system.
No.
It was a structural redesign that changed how a human being physically enters the workspace.
And that redesign provides unobstructed 270 to 360-degree visibility.
Which is huge.
On an active site in Las Cruces, with trucks, personnel, and materials constantly in motion, lateral visibility is paramount.
Yeah.
Safety in this context isn't merely an HR compliance metric.
Right.
It is a critical component of operational efficiency. An operator who can clearly see their surroundings works faster.
Makes more precise movements.
Exactly, and suffers less cognitive fatigue over a long shift.
Now that we have an operator sitting safely inside this side entry cab, we have to look at how the machine itself interacts with the radically different terrains across New Mexico.
Oh.
Navigating a paved industrial park requires a completely different mechanical foundation than operating in the rugged foothills of the Oregon Mountains.
Very.
Fleet managers have to choose between two distinct platforms, the wheeled skid steer and the compact track loader.
The wheeled skid steer, while utilizing 4 heavy-duty pneumatic or solid tires, is optimized for hard, flat surfaces.
Like what?
Warehouses, industrial concrete floors, and large asphalt parking lots. The primary advantage of a wheeled footprint is faster cycle times.
Right, because on pavement, wheels offer significantly lower rolling resistance.
Exactly.
The machine can scoop material, pivot, travel to the dump site, and return much faster, which effectively lowers the operational cost per scoop. Furthermore, wheeled machines have a lighter overall footprint, which drastically lowers mobilization costs.
Right.
They consume less fuel during transit and require less intensive trailer setups to move between jobs.
But, the moment you transition off the pavement and into the rough, slippery, or loose soil, the kind common in mountain foothills or remote agricultural zones,
Sure.
wheels lose their efficiency. That is where compact track loaders, which utilize heavy, continuous rubber tracks, become essential.
Okay.
The driving physics principle here is flotation.
Yes. The sources used an incredible analogy for flotation, comparing it to wearing snowshoes.
I loved that analogy.
It's perfect. If you walk into deep snow wearing heavy boots, the concentrated weight drives your foot straight down.
Right, you just sink.
You just sink. But a snowshoe distributes your body weight over a much larger surface area, drastically reducing the ground pressure so you remain on top of the snow.
Exactly.
Heavy rubber tracks do the exact same thing for a multi-ton machine operating on soft desert sand or deep mud. They disperse the load, preventing the chassis from sinking.
Because maintaining traction and keeping the machine above grade is the only way to sustain productivity in compromised terrain.
Okay, but I want to challenge the economics of that.
Okay, go for it.
If tracks provide superior traction, eliminate the risk of getting stuck, and offer immense stability on uneven ground, why aren't they the universal standard? I mean, why purchase wheeled machines at all if tracks offer such a massive capability upgrade?
Because applying the wrong footprint to a surface destroys profit margins.
Really? How so?
Well, if a contractor operates a heavy rubber-tracked loader on hot, abrasive asphalt for a week, the friction will shred the undercarriage and destroy the tracks.
Oh, wow.
And those are exceptionally expensive to replace. Additionally, the sheer friction of tracks on pavement drastically reduces travel speed.
Oh, so you lose those fast cycle times we talked about.
Completely nullifies them. Tracked machines are also substantially heavier, increasing fuel consumption and requiring specialized higher capacity trailers for transport.
So it all comes down to aligning the physical footprint of the machine with the economic reality of the terrain.
Exactly.
And that concept of maximum utility brings us to the attachments.
Right, the modularity.
Yeah, the power of these machines lies in their modularity. A single loader acts as a primary power plant for dozens of specialized tools.
By utilizing auxiliary hydraulics, operators can swap a standard bucket for an earth auger, transforming the machine into a high-torque drilling rig for sinking wells or setting heavy fence posts.
Oh, that's smart.
Alternatively, they can attach a heavy-duty rotary mower to clear dense brush for a new commercial development, or even to bale hay on a large ranch.
The sources from Southwest JCB highlight a very specific, revolutionary machine in this category, the teleskid.
Oh, the teleskid.
Yeah. This is the world's first skid steer equipped with a telescopic boom. Rather than simply lifting in a fixed radial or vertical arc, the arm physically extends outward.
And engineering a telescopic boom on a compact frame is an incredible feat of physics.
I bet.
It requires managing dynamic weight distribution and hydraulic pressure constantly. As the boom extends forward with a heavy load, the machine's center of gravity shifts dramatically,
which allows operators to reach over tall retaining walls, load high-sided trucks from one side, or even dig below grade on complicated, uneven sites.
Yeah.
It operates as a hybrid between a traditional compact loader and a crane, offering an immense strategic advantage on crowded job sites.
Absolutely.
And this level of mechanical versatility is heavily driving the massive federal road and bridge infrastructure projects happening across the region.
The civil works applications rely heavily on applied physics, particularly when we look at compactors and rollers.
Okay.
Constructing a highway requires fundamentally altering the structural density of the earth before any asphalt is laid.
You can't just pave over loose dirt.
Right, no. These massive rollers use dynamic compaction, often employing internal vibratory mechanisms, to physically force the soil particles closer together, eliminating air voids.
Wow.
They're changing the molecular arrangement of the ground so that it can withstand the dynamic rolling weight of thousands of vehicles a day for decades.
Without buckling or developing structural shear planes.
Exactly.
Okay, so pushing high-tech iron to its absolute limit in brutal, hot, dusty conditions guarantees extreme wear and tear.
It's inevitable.
For a commercial operation, purchasing the machinery is only a fraction of the business equation.
Yeah, the true determinant of profitability is the support ecosystem that keeps the equipment out of the shop.
Right.
Our sources focus extensively on how Southwest JCB, operating out of 461 Pioneer Place in Las Cruces, structures this back-end support.
Right. Down on Pioneer Place.
Yeah, they operate entirely on a partner mindset, explicitly targeting a zero downtime philosophy.
Because when downtime equals lost revenue and massive penalty fines, a dealership cannot just act as a point of sale.
Right.
The partner mindset means maintaining a facility staffed with factory-trained technicians who possess the highly specialized diagnostic skills required to service modern hydraulic and electronic systems.
And the technology integration bridging the machines and the technicians is incredible.
Yeah, tell me about that.
They utilize a telematics system called LiveLink.
Okay, LiveLink.
This allows fleet managers to completely abandon reactive maintenance.
Where you just wait for it to break.
Right, where you simply run a machine until it breaks and instead transition to predictive maintenance. Telematics acts as a continuous digital tether between the machine and the service center, transmitting live sensor data directly to the technicians.
It's incredibly similar to the telemetry systems used on a Formula One pit wall.
Oh, that's a great comparison.
Like in F1, engineers monitor real-time data on oil pressure, engine temperature, and hydraulic flow. They can spot a pressure drop in a specific valve and instruct the driver to make an adjustment before the driver even feels a loss of power.
Exactly.
LiveLink does exactly that for heavy machinery. It's like a smartwatch for a tractor that tells the doctor you're sick before you even feel symptoms.
That's spot on.
It monitors the engine control unit, the CAN bus data, hydraulic load cycles, and fuel burn rates remotely.
And the machine is transmitting predictive failure codes to the technicians before the operator on the ground notices any drop in performance.
Which is huge.
That predictive data allows the factory-trained technicians at Pioneer Place to order the specific replacement part and schedule a targeted rapid repair during off hours.
Saving the spud date.
Right. That completely eliminates the scenario where a catastrophically broken machine sits dead on a job site for weeks waiting for a diagnosis.
Yeah.
But this raises an important question.
Okay.
We are detailing top-tier technological innovations. The PowerBoom engineering, predictive F1-style telematics, heavy-duty telescopic hydraulics.
Right.
How does a local Las Cruces contractor, perhaps a smaller regional startup, compete against giant national civil engineering corporations that possess endless capital budgets for this exact equipment?
Yeah, because the ultimate bottleneck for smaller businesses is financial accessibility.
Right.
And Southwest JCB specifically targets this barrier to entry. The sources detail their aggressive financing structures, most notably offering 0% interest for up to 60 months on select JCB products.
Which is huge. A 0% financing rate over 5 years is a massive market equalizer.
Oh, for sure.
It allows local startups to acquire elite, highly efficient machinery without draining their operating capital or taking on crippling debt loads.
Right.
They can instantly deploy the exact same sophisticated technology used by international conglomerates.
Yeah.
Which fundamentally levels the playing field for contractors in the Southwest region.
It allows the local operators to aggressively bid on those massive federal infrastructure and civil works projects.
Right.
Ensuring that the economic growth generated by these developments stays localized in the New Mexico economy.
It creates a self-sustaining regional ecosystem where sophisticated tools empower local labor.
So what does this all mean? We started by looking at a serene, quiet desert landscape and uncovered a highly strategic, high-stakes industrial ecosystem operating just below the surface. Heavy machinery isn't just about raw horsepower and moving dirt.
No, not at all.
It is a vital economic asset that relies on complex physics, meticulous financial calculations, and human-centric engineering, like the PowerBoom side entry, to physically build the future of the Southwest.
Absolutely.
It manages the logistics in our retail stores, it extracts the deep earth energy, and it compacts the roads that connect every aspect of our lives.
And the continued momentum of that progress relies entirely on localized, high-tech support ecosystems, like the partnership models we see operating in Las Cruces.
Exactly. For any listeners in the region looking to optimize their own commercial fleets, or if you simply want to examine the equipment powering this invisible economic engine, you can connect directly with the local experts.
Yeah.
You can reach Southwest JCB in Las Cruces at 575-524-1671. Their full inventory and specialized attachments are detailed online at swjcb.com locations new-Mexico, where they also host a comprehensive skid steer showroom.
That's right.
You can also pull up their exact location and operation details via their Google business profile.
Because understanding the mechanics beneath the surface completely changes how you view the built environment around you.
It really does. I want to leave everyone listening with a final thought to ponder.
Oh.
We explored how the power boom fundamentally transformed heavy machinery simply by removing one arm, clearing the blind spots, and creating a safe side entry door.
Right.
If a design shift as simple as abandoning symmetrical loader arms completely revolutionized operational safety and efficiency, what other standard traditional designs in our everyday lives are just waiting for a single-arm style paradigm shift? Think about that the next time you look toward the Oregon mountains and hear those engines working in the distance. Thanks for diving deep with us.